Hello guys, today we're going to solve a sample problem in chapter 9 of thermodynamics and heat transfer. The overview of heat transfer. The sample problem is: consider a solid cylindrical rod of length 0.15 meter and diameter of 0.05 meters. The top and the bottom surface of the rod are maintained at constant temperatures of 20 degrees Celsius and 95 degrees Celsius respectively, while the side surface is perfectly insulated. Determine the rate of heat transfer through the rod if it is made of copper with a thermal conductivity of 380 watts per meter Celsius, and the steel which has thermal conductivity of 18 watts per meter degree Celsius, and the granite with a thermal conductivity of 1.2 watts per meter degree Celsius. The given values are: length is equals to 0.15 meter and the diameter of 0.05 meters, with a temperature at state 1 is equals to 20 degrees Celsius and temperature 2 is equals to 95 degrees Celsius. Heat conduction is steady and one-dimensional. The thermal conductivity is also constant, and there is no heat generation. The thermal conductivities are given to be 380 watts per meter degree Celsius for copper and 18 watts per meter degree Celsius for steel and 1.2 watts per meter degree Celsius for granite. Noting that the heat transfer area, or the area normal to the direction of heat transfer, is constant. The rate of the transfer along the rod is determined from the rate of heat transfer equals to thermal conductivity times the area multiplied to temperature at state 1 minus temperature at state 2 over the length, where our length is equals to 0.15 meter and the heat transfer area is expressed as area is equals to pi multiplied to diameter squared over 4. So plug in the values. We have pi multiplied to 0.05 meter squared over 4 is equals to 1.9635 multiplied to 10 raised to the power of negative 3 meters squared. Now we're going to determine the heat transfer rate for the copper with the formula given. The rate of heat transfer equals to thermal conductivity times the area multiplied to temperature at state 1 minus temperature at state 2 over the length. So plug in the values. Since we have 380 watts per meter degree Celsius as our thermal conductivity of the copper, multiplied to 1.963 times 10 raised to the power of negative 3 meters squared multiplied to 95 degrees Celsius minus 20 degrees Celsius over 0.15 meters. So crush out the same units. We have the rate of heat transfer of the copper equals to 373.1 watts. For the heat transfer rate of the steel with the same formula, so we're going to plug in the values. We have 18 watts per meter degree Celsius multiplied to 1.9635 multiplied to 10 raised to the power of negative 3 meters squared multiplied to 95 degrees Celsius minus 20 degrees Celsius over 0.15 meter. So crush out the units again. Then we will have 17.7 watts as our heat transfer rate of the steel. Next, we're going to determine for the rate of the heat transfer of the granite. With the same formula, the rate of heat transfer equals the thermal conductivity times the area multiplied to temperature at state 1 minus temperature at state 2 over the length. So plug in the values, we have 1.2 watts per meter degree Celsius multiplied to 1.9635 times 10 raised to the power of negative 3 meters squared multiplied to 95 degrees Celsius minus 20 degrees Celsius over 0.15 meter. Then crush out the same units again. Then we will have 1.2 watts as our rate of the heat transfer in granite. So that's all for today, guys. Thank you for watching.